The Krapina eagle talon jewelry. In 1999, a museum curator in Croatia pulled 8 white-tailed eagle talons from a storage drawer. They had been sitting there for nearly a century, excavated from Krapina Cave between 1899 and 1905 by Dragutin Gorjanovic Kramberger, and then quietly forgotten. When David Freyer of the University of Kansas finally examined them under modern analysis in 2015, what he found rewrote the story of human consciousness. The talons were not food waste. They were not tools. Under magnification, they showed deliberate cut marks at identical anatomical positions across multiple claws, consistent with hide or sinew removal for stringing. The edges showed polishing wear, the kind produced by repeated contact with soft material, the wear pattern of something worn against skin or leather. These were ornaments, jewelry, and they were made by Neanderthals at least 80,000 years before our species set foot in Europe. White-tailed eagles have a wingspan of over 2 meters. They are apex predators. They do not die conveniently in places where scavengers can find them. To collect 8 talons, someone had to actively hunt these birds, which means planning, specialized tools, and detailed knowledge of eagle behavior. Then they had to process the talons, string them, and wear them. A companion discovery at Cueva de los Aviones in Spain, published in Science Advances in 2018, pushed Neanderthal personal ornamentation back even further, to approximately 115,000 years ago. That makes these the oldest confirmed jewelry in human history. Not Homo sapiens jewelry, Neanderthal jewelry. For 150 years, the scientific consensus was that Neanderthals were cognitively primitive, incapable of symbolic thought. They were the cautionary tale we told about what intelligence looked like before it fully arrived. Krapina didn't just challenge that story, it dismantled it, one talon at a time. The desire to decorate yourself, to mark your body as something that carries meaning, is not a byproduct of civilization. It is not something agriculture unlocked or writing codified. It is older than our species. It may be the oldest impulse we know of. Neanderthals looked at a dangerous predator and saw not just a threat, but a symbol. They hunted it, wore it, and told the world something about who they were. 80,000 years before we arrived, they were already asking the question we still can't stop asking. What does it mean to be more than an animal? The Denisovan Blueprint. In 2010, a single finger bone pulled from Denisova Cave in the Altai Mountains of Siberia changed everything we thought we knew about the human family. Svante Pääbo's team at the Max Planck Institute for Evolutionary Anthropology extracted DNA from that fragment and discovered something that had no category. It wasn't Neanderthal. It wasn't Homo sapiens. It was something else entirely. A previously unknown species of human that science had never named, never described, and never imagined. Pääbo won the 2022 Nobel Prize in Physiology or Medicine for that work. The Denisovans are the most significant paleontological discovery of the 21st century, and we have almost nothing physical to show for them. 4 confirmed specimens, a finger bone, a toe bone, 2 teeth, and a partial skull fragment represent the entire physical archive of a species that ranged from Siberia to Southeast Asia. No burial sites, no tools definitively attributed to them alone, no cave art, just fragments. And yet, their DNA is in billions of living people right now. Modern Melanesians, including Aboriginal Australians and the people of Papua New Guinea, carry 4 to 6% Denisovan DNA. Tibetan populations carry a specific Denisovan gene variant called EPAS1, which enables extraordinary oxygen efficiency at high altitude. It is the biological reason Tibetan people can live and work above 4,000 meters when lowland populations would suffer severe altitude sickness. That gene does not exist at functional levels in any other population on Earth. The Denisovans didn't just survive. They contributed something irreplaceable to human survival in one of the world's most extreme environments, and they did so from a genetic heritage we didn't even know existed until 15 years ago. The Xiahe mandible, found in a Tibetan monastery cave and confirmed as Denisovan in 2019, places this species on the Tibetan plateau at least 160,000 years ago. They were living at altitude in an environment most modern humans cannot tolerate, long before the gene that helps us tolerate it had been passed on. And the Denisovan genome itself contains traces of interbreeding with at least 2 additional archaic human populations that have never been identified, suggesting the human family tree contains entire branches we haven't found yet. We spent centuries mapping ancient civilizations, their temples, their trade routes, their migrations, and we thought we understood the broad shape of human prehistory. Then, a single finger bone in a Siberian cave revealed that the real history of our species was written not in stone, but in us, in the blood of billions of people carrying the genetic memory of ancestors we still can't name. The Toba bottleneck. 74,000 years ago, the human population of Earth collapsed. Not to millions, not to hundreds of thousands. Genetic evidence published by Lynn Jord and Henry Harpending suggests the entire species was reduced to somewhere between 3,000 and 10,000 individuals, possibly fewer breeding pairs than currently live in a mid-sized American town. Every person alive today is descended from whoever survived, and the cause was likely the largest volcanic eruption in the last 2 million years. Mount Toba, a supervolcano on the island of Sumatra, erupted with a force that ejected 2,800 cubic kilometers of material into the atmosphere. The resulting sulfuric acid aerosols almost certainly triggered a volcanic winter, dropping global temperatures by an estimated 3 to 5 degrees Celsius for up to a decade. The ash layer Toba left behind stretches from the Indian subcontinent across Southeast Asia and into East Africa, a geological timestamp preserved in the rock record everywhere that early humans lived. Stanley Ambrose of the University of Illinois proposed the Toba catastrophe hypothesis in 1998, linking the eruption to the genetic signature that still marks every living human. That signature is this: Homo sapiens has dramatically lower mitochondrial DNA diversity than any other large mammal of comparable range. Chimpanzees, occupying a fraction of the territory humans eventually colonized, carry 3 to 5 times more mitochondrial diversity than we do. That uniformity is the fingerprint of a bottleneck, a moment when the population collapsed so severely that almost all genetic variation was wiped out. What survived was a narrow slice of human possibility, and from that slice, everyone alive today descended. The probable survivors were coastal foragers living on the southern tip of Africa. Christopher Henshelwood's excavations at Pinnacle Point, published in Nature in 2007, reveal a small human population that had learned to exploit shellfish during this period, a food source largely invisible to competing mammals and largely unaffected by the inland ecological catastrophe Toba triggered. The people who survived weren't the strongest or the most numerous. They were the ones who figured out how to eat what no one else was eating. Humans are extraordinarily uniform at the genetic level. Populations that look visually distinct, that speak unrelated languages, that built radically different civilizations, are genetically closer to each other than 2 troops of chimpanzees living in the same forest. That closeness is not a sign of how alike we are. It is the scar of how close we came to not existing at all. Göbekli Tepe's reverse causality. On a hilltop in southeastern Turkey, 11,600 years ago, someone organized enough labor to move 200-ton limestone blocks, carve them into T-shaped pillars covered in lions, vultures, scorpions, and abstract symbols, arrange them into precise circular enclosures, and build the most sophisticated structure that existed anywhere on Earth at the time. No pottery, no metal tools, no writing, and no agriculture. Klaus Schmidt of the Max Planck Institute began excavating the site in 1994 and spent the rest of his life trying to explain what it meant. The site is Göbekli Tepe, and it is the oldest temple ever found. Every model of human development says the sequence runs in one direction. First, you develop agriculture, which creates food surplus. Surplus enables permanent settlement. Settlement allows population growth. Population growth produces social complexity. Complexity generates monuments. That is the story. Göbekli Tepe says the story is backwards. The pillars stand 5.5 meters tall. Over 200 have been identified across 20 circular enclosures, and only approximately 5% of the site has been excavated. The animal bones found in the fill are 95% gazelle, suggesting massive, repeated feasting events that must have drawn people from across a wide region. There is no evidence of permanent habitation at the site. No hearths arranged for daily cooking. No domestic debris. No middens. People came to Göbekli Tepe. They did not live there. And they built something that required coordinating the labor of thousands of people who had no cities, no kings, and no grain stores. Schmidt's hypothesis before his death was that the causality ran in reverse. The temple came first. Feeding the thousands of workers required to build and maintain it required reliable food production. The need to feed a religious site may have been the pressure that forced the invention of agriculture. A 2006 genetic study found that the wild ancestor of domesticated einkorn wheat grows within 30 kilometers of Göbekli Tepe. The farm in this reading was not the foundation of civilization. It was the logistics solution for a monument that already existed. Then, sometime after its construction, the entire complex was deliberately buried. Not by erosion, not by neglect. Clean soil was brought in and used to seal the enclosures in phases, a process that required as much organization as building them. Whoever did it knew what they were covering. They chose to cover it anyway. 11,000 years later, we still don't know why. We built a cathedral before we built a barn, buried the cathedral on purpose, and left no explanation. The silence is the loudest thing about it. Murujuga's living astronomical record. On the Burrup Peninsula of Western Australia, baking in desert heat above a rust-red coastline, there are more than 1 million individual petroglyphs carved into rock. Not painted, carved, pecked into stone by people who returned to this place across tens of thousands of years, layering image over image until the rock itself became a library. Murujuga, as it is known to the Ngarluma and Yaburara peoples, is the largest and densest rock art complex on Earth, and some of what is carved there should not be possible to explain. The images include animals that are extinct. Researchers have identified depictions consistent with Geniornis newtoni, a giant flightless bird that died out approximately 40,000 years ago, and Thylacoleo, the marsupial lion, which disappeared around the same time. If those identifications are accurate, and the academic debate continues, then some of these carvings were made at or before the extinction events they depict, placing the beginning of the Murujuga record at or beyond 40,000 years ago. Archaeoastronomer Dwayne Hamaker has documented engravings that appear to track the Pleiades star cluster, which Aboriginal Australians have used for millennia to signal the start of the wet season. Ray Norris of the CSIRO has argued that certain panels constitute the world's oldest astronomical record. What makes this extraordinary is not the claim alone, but the corroboration. Aboriginal oral traditions, documented by ethnographers in the 19th and 20th centuries, contain specific star lore for the Pleiades, Venus, and Jupiter that matches the mathematical positions of those bodies thousands of years ago. The rock record and the oral record agree across a span of time, longer than all of written history combined. This is not interpretation without a key. The key survived. The people whose ancestors made these images still exist, still carry the knowledge of what they mean, and are still watching as a $6 billion liquefied natural gas facility operates on the adjacent land, exposing the rock art to industrial heat and chemical weathering that no amount of academic concern has fully stopped. Most ancient mysteries are mysteries because the culture that created them vanished. Murujuga is different. the culture didn't vanish. The oldest observatory on Earth may be a red rock face in the Australian desert, and the instruction manual may still be in the heads of the people whose ancestors built it. We are not missing the translation. We are choosing not to listen. The missing copper of Isle Royale. In Lake Superior, accessible only by water, there is an island that hides one of the most disorienting archaeological puzzles in the Western Hemisphere. Isle Royale and the adjacent Keweenaw Peninsula in Michigan contain more than 5,000 individual mining pits, cut into ancient rock by people of the Old Copper Complex culture, working from approximately 5,000 to 1200 BC. From those pits, an enormous quantity of pure native copper was extracted. The estimates vary so dramatically that scholars still argue about them, but the volume was immense, hundreds of thousands of kilograms by conservative reckoning. The copper is almost entirely gone. No one knows where it went. Native copper in this region occurs in a form rare anywhere else on Earth, pure enough to work without smelting. The Old Copper Complex people did not smelt it. They cold hammered it, but cold hammering alone makes copper brittle. What the archaeological record shows is that they used annealing, alternating cycles of heating and hammering that relieve internal stress in the metal and produce a final product with strength approaching modern forged copper. This is not primitive. This is controlled metallurgy, practiced in North America thousands of years before metallurgy is supposed to have developed there. Radiocarbon dating of wooden stakes left in the mines confirms active extraction during the Archaic period. The copper tools produced were traded widely across the continent, but the volume of copper removed from these sites vastly exceeds what the North American archaeological record accounts for. The math does not balance. Something received the copper that we have not found. The timeline creates an uncomfortable coincidence. The Late Bronze Age in Europe and the Mediterranean experienced a severe copper shortage beginning around 1200 BC, contributing to what scholars now call the Bronze Age collapse, a near-simultaneous civilizational failure across the eastern Mediterranean. The Isle Royale mines were operating through that exact window and were abandoned at almost the precise moment the European shortage began. The transatlantic copper trade hypothesis, advanced by researchers including Barry Fell and later others, remains firmly outside mainstream archaeology. But the missing copper is not a fringe claim. It is a documented gap that the mainstream has not closed. Someone mined an almost incalculable quantity of copper from a remote island using sophisticated metallurgical techniques, then disappeared without leaving a destination. That is either the longest coincidence in prehistory or the oldest trade route we have never mapped. Bread before agriculture. In 2018, archaeologists from the University of Copenhagen excavating a fireplace at a site called Shubeika, one in the Black Desert of northeastern Jordan, found something they did not expect. Among the ash and charred organic material were small crumbs. Analyzed under laboratory conditions by Amaya Arens Otegui and her colleagues, the crumbs turned out to be bread, flatbread made from wild einkorn wheat, wild oats, and club rush tubers, ground into flour and baked. The results were published in the Proceedings of the National Academy of Sciences. The date of the bread was 14,400 years ago, 4,000 years before agriculture began. Every introductory history course teaches the same sequence. Humans invent farming. Farming creates grain surplus. Grain surplus enables food processing. Food processing eventually produces bread. Shubeika 1 inverts that sequence completely. The people who baked this bread were Natufian hunter-gatherers, semi-sedentary groups who returned to seasonal campsites but did not cultivate fields. They were making a complex, multi-step processed food product from wild-gathered ingredients at a time when, according to the standard model, they shouldn't have had the technology, the surplus, or the motivation to do it. The process required is not casual. Wild grain had to be gathered, dried, and stored. It then had to be ground, which requires stone tools specifically shaped for milling. The flour had to be mixed with other ingredients and water, kneaded into a workable dough, and then baked at controlled temperature. Arendt's Otegai's team identified 24 different plant taxa in the samples, meaning the recipe was deliberate and specific, not accidental. Here's the detail that changes the entire picture. The caloric math does not work in favor of bread making for survival. Grinding wild grain into flour burns more energy than the bread returns in a hunter-gatherer caloric budget. These people were not making bread because it was efficient. They were making it for reasons we would recognize as social or ceremonial. Sharing it, marking events with it, building community around it. The food came before the function we assigned to it. The kitchen came before the farm. That is not a metaphor. The desire for processed, shared, culturally meaningful food may have been the engine that drove the invention of agriculture, not the other way around. We did not learn to bake because we started farming. We started farming because we already knew how to bake and needed more grain to keep doing it. The global dolmen mystery. 4,000 years before the birth of Christ, on a stretch of Irish limestone plateau in County Clare, someone organized enough labor to drag a capstone weighing approximately 5 tons onto 2 upright supports, balance it there, and walk away. The structure has stood for 6,000 years. It is called Pulnabrone. It is one of approximately 35,000 dolmens, portal tombs of the same basic design, that exist across Ireland, France, Spain, Portugal, Denmark, Korea, India, and Ethiopia. 35,000. On 6 continents, built by cultures that, according to every accepted timeline, had no contact with one another. The Dolmen de la Menga in Andalusia, Spain, dated to approximately 3500 BC, has a capstone that weighs an estimated 180 tons. No consensus exists on how Neolithic builders moved it with the tools available to them. UNESCO has recognized the Korean dolmens of Gangwon Island as a World Heritage Site, noting that Korea alone contains more than half of all dolmens on Earth, clustering in 2 distinct regional styles, a northern table type and a southern capstone on ground type, suggesting organized regional variation within a shared architectural grammar. Many dolmens include a circular hole cut through the capstone. These portal holes range from 20 to 40 centimeters in diameter and show smooth, consistent internal walls, not chipped but ground. The grinding suggests a rotary start technique that produced a clean bore through stone several times harder than modern brick. At the Dolmen de Soto in Spain, archaeoastronomical analysis confirms deliberate solar alignment at the equinox, meaning the structure was not just a tomb, but a calendrical instrument. The standard explanation is convergent architecture. When humans need to cover a burial space, they use large flat rocks supported by upright stones. The form follows the function. That explanation accounts for the shape. It does not account for the portal holes, the solar alignments, or the specific cultural commitment required to move a 180-ton stone using nothing but organized human effort and an engineering method no modern experimental archaeologist has successfully replicated. 35,000 times on 6 continents, people who shared no language, no trade route, and no documented contact looked at a burial and reached the same conclusion. The body needs a massive stone overhead. The stone needs a hole, and the hole needs to face the sun. Convergence explains a lot of things. It does not explain agreement this precise. The Schöningen throwing spears. In 1994, workers at a lignite mine in Lower Saxony, Germany, uncovered something embedded in waterlogged sediment that the excavation director Hartmut Thiem had no immediate framework for. 8 wooden shafts, some still intact, the longest measuring 2.3 meters. Published in Nature in 1997, the spears were dated to approximately 300,000 years ago. No Homo sapiens existed 300,000 years ago. The species that made these spears was most likely Homo heidelbergensis, a pre-human ancestor, and the spears were aerodynamically engineered. The standard assumption about pre-human cognitive capacity is that it was functional but not sophisticated. Stone tools, yes. Fire, probably. But the kind of abstract, forward-planning intelligence required to design a projectile weapon with specific aerodynamic properties that was supposed to come later, with us. The Schoningen spears were made from slow-grown spruce, a wood selected specifically for its density and straightness. Each tip was formed from the densest section of the grain, the hardest part of the tree, positioned at the leading end for maximum penetration. The center of gravity was placed in the front third of each shaft. That is the exact specification of a modern Olympic javelin. Not approximately similar. Identical in principle. The aerodynamic optimization is not accidental, because accidental optimization does not produce 8 consistent examples following the same engineering logic. Associated with the spears were the butchered bones of horses, showing systematic cut marks from multiple individuals working in coordinated sequence, not scavenging, but organized, planned group hunting. This means the makers of these spears were not just individually skilled. They were operating as a coordinated team, with assigned roles, shared intent, and presumably some form of communication, sophisticated enough to synchronize a large animal hunt. The waterlogged anaerobic conditions that preserve these spears are geologically rare. The overwhelming majority of wooden tools made across hundreds of thousands of years of human prehistory decomposed without a trace. Schoningen survived by accident, which raises a question that has no comfortable answer. If this level of engineering existed 300,000 years ago and was preserved only by a geological coincidence, how much of what we assume about the cognitive limits of our ancestors is simply a reflection of what organic material can survive 300,000 years of burial? Neanderthal bitumen chemistry. 60,000 years ago, in the mountains of what is now the Kurdistan region of northern Iraq, someone picked up a lump of raw bitumen from a surface seep, carried it back to a cave, and subjected it to a controlled heating process that transformed it into a stable, adhesive compound for hafting stone tools to wooden handles. This is not a description of instinct. It is a description of chemistry, multi-step, intentional, and repeatable, practiced by Neanderthals at Shanidar Cave long before any human species was supposed to be capable of it. The conventional image of the Stone Age mind is one of reactive intelligence, solving immediate problems with immediately available materials. Bitumen processing does not fit that image. Raw bitumen from surface seeps is not directly adhesive. It must be heated to specific temperatures, approximately 300 to 400 degrees Celsius in controlled conditions, and then cooled in a particular way to produce a workable compound. The process is not intuitive. It requires prior knowledge of what the heating will produce, and deliberate management of conditions to achieve it. What makes this more than a regional curiosity is geography. Bitumen hafted tools appear at Neanderthal sites across Europe, separated by thousands of kilometers and with no established contact corridor between them. At Königsaue in Germany, archaeologists found evidence of birch bark tar production, a separate pyrotechnic process that requires oxygen-controlled slow combustion, a smothered burn that produces tar without fully igniting the bark. 2 different chemical processes, both requiring multi-step planning and non-obvious procedural knowledge, appear across the Neanderthal range independently. The average Neanderthal brain volume, it should be noted, was larger than the average modern human brain. The standard explanation is that Neanderthals were cognitively capable, but culturally static, able to learn behaviors within a group, but unable to innovate beyond them. Bitumen chemistry does not sit comfortably in that category. You cannot stumble into controlled pyrolysis. You have to know what you are trying to make before you make it, which means you have to be able to hold a future state in mind and work backward to the process that produces it. That is not reactive intelligence. That is planning. We call it the Stone Age as if the stone were the point, but the people who lived it were not defined by what they worked in. They were defined by what they understood. And what they understood 60,000 years ago was chemistry, 10 items. 10 discoveries that share a single uncomfortable quality. They fit the evidence and break the story at the same time. The bitumen chemists, the javelin engineers, the dolmen builders, the bread bakers, the copper miners, the astronomers of Murujuga, the temple architects of Göbekli Tepe, the survivors of Toba, the Denisovans living in our blood, and the Neanderthals who hunted eagles to wear their claws. None of them were primitive. None of them were simple. The story we tell about human prehistory is a story of gradual emergence, of capability slowly accumulating until it finally produces something recognizable as intelligence. These discoveries don't fit that story. They suggest instead that the capacity was always there, surfacing and disappearing and resurfacing across hundreds of thousands of years, in species we've dismissed, and populations we've forgotten, in places we haven't excavated, and in materials that didn't survive. The past is not a straight line climbing toward us. It is a depth we have barely begun to sound. Every time we look carefully, something looks back. If any one of these discoveries changed how you see what our ancestors were capable of, the comment section is yours. Which item breaks the standard story hardest for you, and why? Share this with someone who still thinks the Stone Age means simple. And subscribe, because this archive is just getting started.